Hello everyone, welcome to another video. In this video, I am going to talk about a very important interview question, especially for SREs related to system design. The question is how to design a highly available application architecture in cloud. And here I am using the example of AWS Cloud. So this question is going to really test your system design skills, and that's what the interview wants to understand. So I'll try my best to explain this in the easiest way possible. All right, so let's get started. So right now on your screen, you are seeing one application diagram. And if you can explain this in any interview, interviewer cannot say that you haven't worked in a production grade environment ever. Okay, so let me explain the diagram now. This architecture is designed to eliminate single points of failure and ensure high availability, scalability, security, and observability for any production grade application that you want to run on AWS. So here, whatever answer I'm trying to cover, it's from production point of view, like how do you design an application in production? So now the user traffic is going to first enter through Amazon Route 53. So we know that whenever we are using Route 53 as our DNS service, we also get the option to have health check enabled routing. So whenever the traffic is going to enter through Route 53, it's going to provide us with DNS resolution. Along with that, we also get health check based routing, which is going to allow traffic to fail over automatically if any endpoint becomes unhealthy. We can also use Route 53's application recovery controller feature for designing our multi-region disaster recovery strategy for our applications. So this is one of the ways by which you can get multi-region application failover architecture. Then the requests are accelerated through another service called CloudFront. So CloudFront is a service which is going to give us content delivery network, okay, and which can be used for low latency global content delivery basically. So we're going to use this service as well. So the requests are going to go through this CloudFront CDN service for low latency global content delivery. Then we also have a firewall here. It's called Web Application Firewall, WAF. So AWS WAF is going to filter any malicious traffic, and it's going to protect against common attacks such as SQL injection or DDoS attempts before the traffic reaches the application layer. So in my last company, I got one opportunity to design and configure this web application firewall for one of the applications which was using application load balancer. So there I was using this for SQL injection attacks. So in the web application firewall, you have multiple types of traffic that you can block. So here I'm taking the example of SQL injection because I have worked on it in the past. Now, then the application load balancer is going to distribute the incoming traffic across Kubernetes workloads or EC2 instances deployed across multiple availability zones. So here in this example, or here in this question, the interviewer hasn't given me any way by which the applications are being deployed. Okay, he did not mention whether the applications are deployed in EKS clusters, or we are using EC2 instances to host our applications directly there. Okay, so but it can be anything. So we have to ensure that our Kubernetes workloads or EC2 instances, they are deployed across multiple availability zones. It is going to ensure that the application is going to remain available even if an entire availability zone fails or it goes down for any reason. Okay, so that can happen anytime. So we have to ensure that we have high availability in terms of availability zones. Then running workloads across multiple availability zone is critical. Okay, as I mentioned, especially in an enterprise environments, because infrastructure failures or any network issues or AZ level outages are real production scenarios that must be handled gracefully without any customer impact. So that's what we want to ensure. Now I'll talk about the backend part of the application. So now suppose in this example, we have a backend application layer as well. So now just assume that our backend application layer is hosted on EKS for container orchestration. So so in this case, we would want automated scaling rolling deployments, and self-healing capabilities also. Then we can also utilize Redis. So to get the Redis services in AWS, we have something called as ElastiCache. So Redis deployed through Amazon ElastiCache, it's going to act as a high-speed in-memory caching layer, which is going to reduce the database load, and it's going to improve API response times, and it can also absorb traffic spikes during peak demand. Okay, so this is how you can answer this question. Now I spoke about the main application layer. I spoke about the backend layer. Now suppose you have a database layer also. So the primary database layer, just assume that your database is an RDS instance. So your primary database layer, it's going to use Amazon RDS, and in Amazon RDS you can go for multi-AZ, which is going to provide you with synchronous replication, automated failover, and backups as well to maintain database availability during infrastructure or instance failures. Okay, so this is about the three layers. Now I'll talk about the main monitoring and observability perspective. So from an observability perspective, we can use a tool called Prometheus, which is going to collect infrastructure and application metrics. Then we can use a Grafana to provide visualization dashboards. We can use Alert Manager, which can integrate very well with tools like Slack or PagerDuty or any incident response automation tool that we have. Then if I talk about logging, so we can use a tool like FluentBit and OpenSearch, which is going to enable us with centralized logging, or we can also use a Grafana Loki as well. Okay, so centralized logging is handled using FluentBit in OpenSearch, or you can use Grafana Loki also. It's going to enable engineers to troubleshoot the distributed systems efficiently by correlating logs across all the services and nodes. I also want to add here that Prometheus can also be used to collect not just metrics, it can be used to collect our logs data, as well as if we want to use a tracing also. So for tracing, we can utilize a solution called Grafana Tempo, which is really popular, or we can use Jagger also, and the data can be collected in open telemetry way. I've already done one video on this one. You can go check that video if you want to see the hands-on demo and everything. So we can use the Prometheus tool for collecting our metrics, logs, and traces, and that's what we want to achieve in our observability stack here. Okay, so yeah, so this is what our observability stack should look like. Okay, now if I talk about the mature production environments, so this entire infrastructure is typically provisioned and managed using infrastructure as code with Terraform. So all the different tools and technologies that I just spoke about, we would be using an infrastructure as code tool like Terraform, so that it's going to allow us with a repeatable, version control, and auditable infrastructure deployments. Now let's talk about security as well. So the security layer is going to follow a defense in depth approach to protect all the production workloads at multiple levels. Okay, so IAM least privilege is going to ensure that users and services only get the minimum permissions required. It's going to reduce our security risk and blast radius. Then if I talk about security groups and network access control lists, or NACLs, is going to provide network level protection by controlling traffic flow at both instance and subnet levels. Then encryption, it can be enabled both in transit using HTTPS or TLS, and at rest for services like RDS, EBS, or S3 to secure any sensitive data. We can also use AWS Secrets Manager to securely store and manage any credentials which we are using in our architecture, instead of hard coding them inside our applications or our Terraform infrastructure code. So together, these controls is going to help build a secure, resilient, and enterprise-grade production environment. So this is how you can explain this particular question. So this is just going to test your system design capabilities in an SRE interview. So that's all I wanted to cover in this video. I'm going to come up with a lot of interview question and answers on SRE. So please stay tuned and keep watching my channel. Before I go, I also want to talk about YouTube membership program that I'm running on my channel. So if I go to my channel here, and you see there's a playlist, DevOps SRE live training 0 to hero course. So I have 80 videos in total, which is to prepare you for any SRE interview. Here you can see there are multiple videos and the videos are in sequence. So I put a number on each video. So it starts with 1, 2, 3 and so on. So we have 80 videos in total now, and it's going to increase a lot in future. So I'm going to keep adding the videos to it. And if you see here the type of video that I do, so if I go back to my channel, if I filter out with visibility, let's go to content here, content and visibility members. So here you can see the video that I'm trying to provide as part of my YouTube membership program. You see I cover a production Docker file video. I have videos on SRE engineering terms that get you hired. I also have a video on golden SRE signals. I have hands-on demo on SLI, SLO, SLA, where I spoke about one Java Spring Boot application deployed in AWS EKS clusters. So I have a hands-on demo on that. And I have multiple videos on Prometheus and Grafana for distributed tracing, open telemetry based metrics collection. I also have a video on Loki logs. So this, and then I have shell scripting crash course as well. Okay, and I have like multiple videos on all the concepts that you need as part of your SRE interview preparation. So you can check this as well. It's going to help you immensely in your SRE interview. All right, that's all I wanted to cover, and I'm going to see you in the next one. Bye for now.